Hello children, in previous video we had studied about the direction of magnetic field around the straight current carrying conductor, and also we had used Maxwell's right hand grip rule, Maxwell's right hand thumb rule to know the direction of field line. In that what we had studied that if we hold a conductor in our right hand such that the thumb represents the direction of current, then the wrapped finger will represent the direction of magnetic line of force that we had used in straight conductor when current flows in upward direction or in downward direction. Now we will study the magnetic field around the current carrying loop, or we can say if current flows through a circular conductor, then what will be the shape of the magnetic line of force. For that we have taken this cardboard. On this cardboard we have made two holes at A and C, and then we inserted the two end of the conductor through these two holes and then connected the two end to battery and switch. Now we keep the magnetic needle at one end of the conductor here at suppose A, and then we find the direction of magnetic field around it. And before that what we can do that before switching on the current in the circuit in the coil, what we do that we keep the magnetic needle here. This is not coil, we have taken just a circle, just a loop. So we keep the magnetic needle here. We don't see any change in the direction of magnetic needle. Now we switch on the current and then we keep magnetic needle suppose at point A, and then we find the direction of magnetic line of force around this one. Again we keep magnetic needle near the C. So when the current is flowing through the loop, what we find that the magnetic needle gets deviated, deflected from its place, and its north pole starts moving along the circular path, and as the conductor will have two parts here, AB and BC. So suppose at point A, if we trace the path of north end or north pole of magnetic needle, we will get anti-clock. As the current is flowing in upward direction in part AB, so the field line along AB, around AB will be what? Anti-clockwise. So the north pole of magnetic needle will move in anti-clockwise direction. If we draw another field line, again we will find that the north pole is in anti-clockwise direction, and then again we plot, we will find the same thing. We will get circular field line around the conductor at around point A also. Now at point C, if the direction of current is in downward direction, so the field line at point C, if we plot, will be what? Clockwise. Okay, so the north pole of magnetic needle will move in clockwise direction, and the field lines will be circular around this end also. Now if we plot the field lines at the center of the loop, we find that field lines are parallel to each other. These field lines are supposed to be a part of large size circle, so they appear to be a straight line. As you can understand, like this kind of circle will form, and it won't be completed because magnetic field won't reach till there. So this part of field line, which is larger in size, will be like the straight line, and at the center of loop the field lines will be parallel to each other, representing that the field line inside the loop is uniform. As they are parallel to each other, they push each other sideways, and as they are being produced due to the same current, so what will happen that they will push equal force on each other and will get equi-spaced. They will remain at equal distance inside the loop. अब हम क्या कर सकते हैं आपको कि ये जो कंडक्टर है जिससे करंट फ्लो कर रहा है, इसके ईच पॉइंट के चारों ओर इसी तरह का मैग्नेटिक लाइन ऑफ फोर्स होगा, मैग्नेटिक फील्ड इसी तरह का सर्कुलर लूप होगा, और ये जो कंडक्टर है सर्किल के रूप में, लूप के रूप में will behave like little bit more powerful magnet, stronger magnet, as we can understand like this कि ABC जो कंडक्टर था, अगर ये स्ट्रेट होता तो फील्ड लाइन क्या होता, लंबा दूर तक, ज़्यादा डिस्टेंस तक वो स्प्रेड कर जाता, एंड सो ये जो मैग्नेटिक फील्ड का स्ट्रेंथ होता वो कम होता। लेकिन जब इसको आप सर्किल के रूप में बना देते हैं तो इसके सर्किल के ईच पॉइंट के चारों ओर मैग्नेटिक फील्ड बनेगा और दे गेट कंसंट्रेटेड, वो छोटे से जगह में कंसंट्रेट होंगे, इसलिए ये जो लूप बनाएगा वो स्ट्रॉन्गर मैग्नेटिक फील्ड बनाएगा। अब स्ट्रेंथ ऑफ मैग्नेट ड्यू टू द सर्कुलर लूप, करंट कैरिंग सर्कुलर लूप will depend upon the strength of current. Stronger will be the current, stronger will be the magnetic field, and then the number of turns of the loop. If we increase number of turn of the loop, then it will become again coil, solenoid that we call, and then the radius of loop. If the radius of loop is small, then the field line will get concentrated in a small area, so it will become stronger. So finally what we can say, strength of current increases, then the strength of magnetic field increase, radius of loop decreases, then the strength of magnetic field increases, and radius increases, strength decreases. So that's all children for this video. And finally what we can say, that current carrying loop behaves like little bit more powerful magnet, or more powerful magnetic field is produced around the current carrying loop. At the center of loop field lines are parallel to each other, equi-spaced. They represent the uniform magnetic field inside the loop, and these appear to be straight line because they are supposed to be a part of large size circle. That's all for this one, and thank you for watching this video children. This is not exceptional, again I am telling, I have not arranged anything more to make the video, just this thing came in my brain and I started making videos. So watch it. If you understand, comment and subscribe this one also. Thank you so much for watching.